Hello friends, in this video I am going to teach you about narrowband frequency modulation and its mathematical representation. As the name indicates, narrowband frequency modulation is having narrow bandwidth. That is, here the modulation index, that is beta, is very less than 1. Okay, in this video I am also going to teach you about the frequency spectrum of narrowband frequency modulation. Now first let's see what is narrowband frequency modulation. The NBFM, that is narrowband frequency modulation, has small bandwidth. I already told you it is having small bandwidth. That's why we are calling it as a narrowband when compared to the wideband frequency modulation. Here, modulation index beta is less than 1. Okay, whenever the modulation index beta is less than 1, then we call that type of FM is narrowband FM. If the modulation index beta is greater than 1, then the type of FM is known as wideband FM. Okay, its spectrum consists of carrier, upper sideband and lower sideband. In AM modulation also we have three terms in spectrum, that is carrier, upper sideband and lower sideband. As similar to the amplitude modulation, narrowband FM is also having carrier, upper sideband and lower sideband. Okay, now coming to the mathematical representation of narrowband FM. Narrowband FM can be represented by using first standard FM modulated wave expression. Here first let's take the mathematical representation of FM wave. That is S of t is equal to AC cos of 2 pi FCT plus beta sin 2 pi FMT. I already told you in my previous videos how it can be obtained. Okay, this is the mathematical representation of FM wave. Here, by using trigonometric identity, that is cos of A plus B is equal to cos A cos B minus sin A sin B. Here it is look like this only, cos of A plus B. We can use the trigonometric identity, then we can get the A as a 2 pi FCT and B as a beta sin 2 pi FMT. Okay, now apply this formula on the first equation, then we got S of t. S of t is equal to AC. First cos A, that is cos A is 2 pi FCT. Next cos B, cos beta sin 2 pi FMT minus sin A sin B. Okay, now coming to the next step. If in narrowband FM beta is less than 1, hence it is possible to appropriate. I mean, in narrowband FM, I already told you it is less than 1. Less than 1 is nothing but is approximately equal to 0. Okay, when we put the 0 in beta value, then cos 0 will become 1 and sin 0 will become 0. Okay, using that property, here beta value is less than 1, that is approximately it is equal to the 0. So cos of beta sin 2 pi FMT, that is cos of 0 equal to 0 and sin 0 equal to, we have normally sin 0 equal to 0. So here theta equal to theta, that's why I written here sin of beta sin 2 pi FMT is approximately equal to beta sin 2 pi FMT. Okay, now substitute these two terms in this equation. Okay, that is S of t is equal to AC cos 2 pi FCT cos beta sin 2 pi FMT minus sin of 2 pi FCT sin beta sin 2 pi FMT. Then you can get like this, that is substitute equation 3 in equation 2, then S of t is equal to AC cos 2 pi FCT minus sin 2 pi FCT beta sin 2 pi FMT. Okay, now multiply this AC to the inner terms, that is AC cos 2 pi FCT minus beta AC sin 2 pi FCT sin 2 pi FMT. Consider this as the equation number 4. Now we know the trigonometric another property, that is sin A sin B is equal to cos of A minus B minus cos of A plus B by 2. Here it will look like sin A sin B. Okay, now we can apply this formula on it, then we can get the equation, that is S of t is equal to AC cos 2 pi FCT minus beta sin AC by 2 cos of, here A is 2 pi FCT and B is 2 pi FMT. So cos of normally cos of a minus b. So cos of 2 pi fct minus 2 pi fmt minus beta ac by 2 cos of 2 pi fct plus 2 pi fmt. Now coming to next equation, that is, this is the continuation for this equation. Okay, this is the continuation equation, that is s of t is equal to ac cos 2 pi fct minus beta ac by 2 cos of 2 pi minus f cos of 2 pi of fc minus fm into t minus beta ac by 2 cos of 2 pi of fc plus fm into t. Consider this as the equation number 5. Now this is the equation for narrowband frequency modulated wave, that is AC cos 2 pi fct minus beta AC by 2 cos 2 pi of fc minus fm into t minus beta AC by 2 cos of 2 pi of fc plus fm into t. Okay, this is the standard form of narrowband FM. Now we know the AM modulated wave, that is S of t is equal to AC cos 2 pi fct plus mu AC by 2 cos of 2 pi into fc minus fm into t plus mu AC by 2 cos 2 pi of fc plus fm into t. This is the standard form of amplitude modulated wave. Now compare these two, that is narrowband FM wave and amplitude modulated wave. There is at most similar. Here beta is nothing but modulation index, here mu also is nothing but modulation index, AC and AC cos 2 pi fct, and remaining terms are all similar except the sign. Here we have minus sign, here we have plus sign. Except the sign reversal, remaining all terms are the similar to compare to the narrowband FM, to the amplitude modulation. That's why the bandwidth for both amplitude modulated wave and narrowband FM is same, that is 2 FM. Okay, that is 2 FM. Now apply the Fourier transform on the above signal. Above signal is nothing but narrowband FM signal, that is this signal. Okay, this signal. Now if we apply the Fourier transform on this signal, then we get that is S of f is equal to AC by 2 into del of f minus fc plus del of f plus fc minus beta AC by 4 into del of f minus fm plus del of f plus of f minus fm plus beta AC by 4 into del of f minus of f plus fc plus fm plus del of f plus fc plus fm. This is the Fourier transformed signal of the narrowband FM. By using this equation, we can draw the spectrum of narrowband FM. Now let's take this equation and draw the spectrum. That is, first write this equation, that is S of f is equal to AC by 2 into del of f minus fc plus del of f plus fc minus beta AC by 4 del of f minus fc minus fm plus del of f plus fc minus fm plus beta AC by 4 into del of f minus fc plus fm plus del of f plus fc plus fm. Okay, by using this equation we can draw the spectrum of the narrowband FM. First draw the frequency axis. This is the horizontal axis, is the frequency axis. Now let's see, it is the we are going to draw the spectrum for f of s of f. So I write here s of f. Now first consider del of f minus fc. That means here we are plotting the minus fc. Minus fc is nothing but carrier frequency. Here we have minus fc with amplitude AC by 2. So minus fc with amplitude written AC by 2. Now coming to plus fc. Here f plus fc is nothing but plus fc is nothing but frequency of the carrier signal, that is plus fc with amplitude AC by 2. The amplitude AC by 2. Now coming to here, del of f minus fc minus fm. Here we need to consider this term, that is fc minus fm. Where is fc minus fm? Here we have fc minus fm with amplitude minus beta AC by 4. With amplitude minus beta AC by 4. In order to represent the minus value, we need to take the arrow to the downward side. Here we represent the plus AC by 2. That's why I represent the plus AC by 2 to the upward side. That is arrow going to upward, and here the arrow going to the downward. That's why it represents the minus beta AC by 2. Now the next term is del of F plus Fc minus Fm. Here also Fc minus Fm. Where is Fc minus Fm? Here the same thing here is Fc minus Fm, that is beta AC by 4. Now coming to the del of F minus Fc plus Fm. Now where is Fc plus Fm? It is the Fc plus Fm with the amplitude beta AC by 4. Here also amplitude beta AC by 4, not minus beta AC by 4. That's why I move this arrow to the upward side and I represent this as a beta AC by 4. Now coming to the last one, that is del of F plus Fc plus Fm. Okay, del of F plus Fc plus Fm is nothing but the same term. Okay, there's nothing but the same term, and if we consider the same terms in negative axis, then we get like this. Okay, finally this is the frequency spectrum of narrowband frequency modulation. I hope you understand this topic. Thank you for watching this video.